some boards. Again, I just want to see the object moving at a constant velocity. So you've got your boards. I'm just taking a peek to see what we've got. A position versus time graph and a velocity versus time graph. Looks like I see a lot of very similar things. So I just want to make sure that I am seeing and doing the same thing you are. So as this one starts, the velocity stays at a constant positive value, right? So that's pretty easy to graph a velocity versus time graph. Would you agree? Constant positive value, bam. And your displacement or position versus time graph, most of you had something that looked like that. Couple quick questions for you. How do you know that it starts right here? Because it specifies, doesn't it, that it starts at 0? Yeah, absolutely. And then it's moving at a constant positive velocity. So how did you know that you needed a graph that looked like this, where the position goes like that? As time goes on, it moves further, right? From there, we can find that velocity graph. So we're going to look at the what of this graph to figure out the slope, right? And the words that we can use to describe the slope of this line, I'm going to write this down. You might want to write this down as well. I'm not sure, but if you do, you're very welcome to. The slope of this graph is change in distance over time. I would totally agree. Tell me about the value of it. Is it positive or negative? It's positive, right? The slope is positive. And does the slope change as time goes on? No. So I'm going to call that a positive constant slope. Okay. I'm trying to lead you here because this is where we're going next. Tell me about the value for the velocity. It's positive, and it's what? Holy cow, that's pretty great, right? The value, or the values here, are positive and constant. Fantastic. Whoa, hello. I didn't mean to do that. There we go. All right. Go ahead and erase your boards. Pass your board to somebody else at your table that hasn't drawn yet. And give them the opportunity to do C and D. Put them on the same board. Okay? And I love it because it leads us to some really good learning. Okay? So let's talk about the situation with an object starting at rest and moving at an increasing velocity. So I'm going to start with the velocity graph again because it seems like I can handle that. That is something that can be doable. Okay, so it starts at rest. So where does that mean that my velocity needs to be at time equals 0? Needs to be at 0. So we got that far. I'm going to start here. And then what is it going to do? It increases. Now, when I was walking around looking at your boards, I saw kind of two different things. One of the things that I saw looked like this. Come on, silly thing. So I want to look at this graph. In this case, is the velocity increasing?
Yes.
For sure it is. It's increasing in this little stair-step pattern. Would you agree? Yeah? So it's maybe like it's at 0 for a second, and then it's at 1 for a second, and then 2 for a second, and 3 for a second. Yeah. So it's not wrong. That's okay. But it's really interesting because that's not what I had intended for you to write down. And I think that the reason that it's in your head this way is because every graph we've done so far with velocity versus time has been a bunch of horizontal lines. Are you with me there? When I was doing all of that walking back and forth, it was all a bunch of horizontal lines. And the reason for that is because I was moving in different ways, but every time I was moving with a constant velocity, right? I moved really fast at a constant velocity, really slow, then I stopped. All of those velocities were constant. In this case here, whether the words read this way to you or not, what I was intending was for that velocity to be continuously increasing. Does that make sense? Yeah. So that's like if I'm sitting at a red light or sitting at a stop sign in my car, and then I put my foot on the gas, right? So I'm at a velocity of 0, which is what it says, starting at rest, and then I'm going to increase and increase and increase and increase. Is my velocity versus time graph going to look like this? No. What be a straight line, like a horizontal line. It's going to have some slope. Are you with me there? Is that okay? Yeah? That's what we're saying. So if you had this, that's okay because we're learning and we're growing and we're getting this now. Okay? But what I would like for this graph to look like, so you might want to fix this if it didn't look like this before. I want this velocity to go up, 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 up. Okay? It starts at rest and then it moves at an increasing velocity. So as time goes on, velocity keeps getting bigger and bigger. Breaking it down into little pieces like that, I will tell you for those of you that want to know this, okay, that's really what they do in calculus. So if you're there, if your trajectory of math will get you to calculus, that whole idea of breaking things down, that's exactly what they're going to do. That's how they're going to think about it. For today, though, and in physics, we're going to talk about a constant increase in velocity. Okay? We doing okay? Okay, awesome. So that's our velocity versus time graph. What does the position versus time graph that goes along with that look like? Can you show me or fix it if you feel like you need to fix? Show me what you've got. I saw a lot of really lovely graphs for that. Yeah. I see some curves on there. Yeah? Ben, put it away, sweetheart. Okay. I see a lot of this kind of a thing. Now, for some of you in math, you may have had a love or hate relationship with these, but we're going to embrace it and we're going to learn to love it. What is this a graph of? It's not a line anymore. What is this? Starts with a P. Parabola. It's a parabola. And the reason that we love parabolas in math is because we use them in physics. Okay? There is so much application of the parabola in physics. You'd be like, oh my gosh, that's great. Because I used to teach, I taught math for a long time too. And I'll be honest, when you learn the parabola, you're like, well, I'm talking about parabola. What? Like, what are we doing with it? This is why you care. Right now, today, welcome. Let's talk about it. I want to look back at this one here. Here, on the first set, the values of the velocity were constant and positive. If you were going to describe the values in this second set for the velocity, what words might you use? Would you use positive? Sure, it's in the first quadrant, right? They're all positive values, so I would say absolutely you'd say positive. Are the values of the velocity constant? No. They're not. They get bigger and bigger and bigger and bigger and bigger over time. What would we call that? Increasing? And do you remember we saw here that the values of constant and positive were the same as the slopes here? Take a look down here, friends. The values for the second one are positive and increasing. The slopes here. What? Let's see. So again, for some of you, this makes total sense. For some of you, are like, this is crazy town talk. Let me show you. If you've taken geometry, you've heard of the word tangent, right? Okay. A tangent is a line that touches a circle or a curve at one point. That's what we're going to draw. We're going to draw tangent lines. The tangent lines for this represent the slope. They show the slope at any given time. And what happens to the slope as time goes on? Do you see how it gets steeper and steeper and steeper? So the slope here increases. And oh, by the way, it's always positive. Do you see that? Always positive. That's not a coincidence. That's physics right there. That's what that is, right? So the slope values here are positive and increasing, and the actual values of velocity are positive and increasing. See that? It's a beautiful thing. Okay? Questions on this before we move on? What's up, my dear?
Okay. So if the line is like on the position versus time, if it's like this and that, what does it mean? Like, what is that?
Like, what would that look like?
Yeah.
So
what would it? Like, what would it measure?
Yeah. Can I go ahead and draw that so everybody can see it? So you have a velocity versus time graph. That color's not going to show up. It was like 0. Is that right? Like this? And then it was like this. Okay. So we're just trying to like kind of put this all back together. I love that question. So talk to me, friends, about what the velocity is doing right here. Nothing. So what's the object doing? It's standing still. So let's break it down like we just did the other ones. The value here is constant and 0. Is that okay? Which means that the slope here would need to be constant and 0. So if you were starting from the beginning of the story, then it's probably going to sit like this. Maybe it's not starting at the origin, though, so it might be starting somewhere else. Is that okay? Okay, so then right here, we've got a velocity value that is constant and positive. And so that means that the slope here needs to be, yeah. So it'd be something like that. And so if I was going to act that out, I would stand on the origin, I'd say go, and then I'd go like this.
So the only difference between the other one is that one's like stock pickers.
This one versus the first one that we did?
I'm not the position.
The velocity, yeah. So you're comparing the green one down here to the red one, is that what you're saying? I just want to know what you're looking at.
The green one and the blue one.
Oh. These guys?
Yeah, but I get it now.
Okay. Are you sure? Okay. Thank you for asking that question. I really appreciate that. Other questions that you have right now? Looking at these graphs. We're going to spend lots of time with graphs. We're going to love them and understand them and embrace them in all of their glory. So I want to make sure you're feeling okay. All right. Is that a question or a stretch?
No.
Okay, just making sure. All right. What I would like you to do right now is to erase your boards and put those away. Get out your physics or the marble on a ramp lab. You're going to stay in your seats for just a minute, and then we will finish this up, okay? Put the whiteboards away. We're not going to use them anymore today. Thank you for checking, though. I appreciate that. To now have your lab out, I just want to get our brains back to the marble on a ramp lab. So we did this yesterday. For those of you that weren't here, we're just going to kind of go through a really quick rundown of what happened. We had a marble and a ramp. It's pretty exciting. And we released the marble from the top of the ramp, and we watched it roll down the ramp. I know. AJ, is your mind just blown by the excitement that you missed? I'm sorry about that, but yeah, so we're getting you caught up now, okay? And so we released the marble from rest. We set a metronome to get the clicks, click, 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 and then we took data. And so you have collected that data in your data table, okay? And that data table may need to be cleaned up a little bit, and if it does, this is going to be your opportunity to do that, okay? I want to let you know that you do not need to convert your times into seconds. You can just say time, and then in parentheses for your unit, you can just use clicks. That is absolutely fine. If you really want to convert it to seconds, I can help you with that. But for my purposes, it does not matter. You are just going to call them clicks, okay? You got your trials. The reason that we do trials is to find an average, okay? And so you're going to have this really nicely labeled data table. If you don't yet, that's okay, because you're going to have a minute to do that. And then we're going to process this data, okay? Once I tell you to go, and that'll be in just a moment, you're going to take the following things, 4 things. I'll write them down here so that you know what they are. You're going to take, come on, silly thing. There we go. You're going to take your lab. You're going to take a pencil, a calculator, and a separate piece of paper. Don't go anywhere yet. To your assessment spot. When you do that, friends, you are going to work on, in just a minute, don't go, okay, I'm sorry, pretend I didn't say that. Stop wiggling, stop moving, and listen to me for just a moment, please. Shh. Okay. You will be assessed, once you turn this in, on data collection. That means that you need to have a nice deep data table. I should be able to take it to Mrs. Ellickson or Mrs. Hughes or anybody else, any other science person, and they should be able to understand what you did based on your data table. Okay? And then you're also going to do your graphing for data processing. Okay? So those two things are going to go in your lab. And then these two questions, the discussion questions, should be answered on separate paper. Okay? Because you're not going to turn those in. We're going to use those to start the discussion after you finish. All right? Now you may move to your assessment spots, and you may begin, okay?
Can I have another?
Yes, I was going to say, if you need a new sheet because your sheet got messy and you just want to clean it up a little bit, I'm very happy to get you one. That is absolutely fine. Yes. If there's nobody else that's sitting there, then that's fine.